Question 27. The diagram shows the location of three places, X, Y, and C. Y is on a bearing of 120 degrees and 15 kilometers from X. C is 40 kilometers from X and lies due west of Y. P lies on the line joining C and Y and is due south of X. Part A. Find the distance from X to P. The question is asking for this distance here, XP, and that's the side of this particular right-angled triangle, XPY. Now it's given that the bearing of Y from X is 120 degrees. And this angle here must be 60 degrees since two adjacent angles on a straight line are supplementary or add up to 180 degrees. So now we have a right-angled triangle where the hypotenuse is known, it's 15 kilometers, and we have a known angle. So we can apply regular right-angled trigonometry or SOHCAHTOA to work out the length of this side here, which represents distance XP. So this is our angle. This is the adjacent side. This is the hypotenuse. So using SOHCAHTOA, we need to apply the cosine trigonometric ratio. So adjacent divided by hypotenuse, or adjacent over hypotenuse, is equal to cos theta. So XP divided by 15 is equal to cos 60 degrees. Multiplying both sides of this equation by 15 to make XP the subject, we get XP is equal to cos 60 degrees times 15, which equals 7.5. Therefore, the distance from X to P is 7.5 kilometers. Part B. What is the bearing of C from X to the nearest degree? To find the bearing of C from X, we need to focus on this triangle here, triangle XPC. And it just so happens that triangle XPC is also a right-angled triangle, so we can apply regular right-angled trigonometry for this part also. So to find the bearing of C from X, we need to find this angle here, which I've labelled with theta, and we add that to 180 degrees to give us the bearing that we want. But first, to find angle theta. Now, I've let theta equal angle PXC, so that's here, and XP is equal to 7.5 kilometers that we found in part A. So going back to our triangle, so we have a right-angled triangle, hypotenuse 40, the adjacent side 7.5, and again we can apply the cosine ratio to find the value of this angle theta. So cos theta is equal to adjacent over hypotenuse, or 7.5 divided by 40, making theta the subject by taking inverse cos of both sides, or moving the cos over to the other side and using shift cos on your calculator. So it's this cos with the -1. We have theta is equal to inverse cos of 7.5 divided by 40. And that evaluates to 79.193 degrees correct to 3 decimal places. Now the question is asking for the bearing correct to the nearest degree. So to get the bearing of C from X, we take 180 degrees. So back to our diagram, that's 180 degrees. Add that on to the value of theta that we just found, which is 79.193. And we get 259.193 degrees, which is 259 degrees correct to the nearest degree.